Okay, we're going to work on unit 5.8. We're going to solve radical equations and inequalities. So a radical equation, if you're using your notes, is an equation that has variables in the radicand. Oops, sorry. Okay. So the next part says, if we're going to solve a radical equation, or to solve radical equations, raise each side of the equation to the same power, oops, as the index. This will eliminate the radical. Okay? You have to, you must check your work. Sorry, check your answer. And the reason is because you may end up with an extraneous solution. When you square both sides or cube both sides, sometimes it creates a solution that doesn't work in the original equation that has the radical in it. So you may end up with an extraneous solution. An extraneous just means a solution that does not work in the original radical equation. It works after you square both sides or cube both sides, but it doesn't work otherwise. Now here's the steps. And I cannot emphasize the first one enough. Whenever people get questions wrong on the test, it's because they don't do this first step. You have to get the radical, you have to, or you create all kinds of problems for yourself. You have to get the radical by itself before you do anything else. And I see so many people, this is why they end up getting it wrong. They don't get the radical by itself, and then they try to square or cube or bring to the fourth power each side, and they make a big mess of it. So you have to get the radical by itself. Okay, then you have to determine the index. So look at the index, the little number on the radical, and raise both sides of the equation to that power. Now you're just going to solve using the rules of algebra. And then the last step is important. You have to check your answers and make sure that not one of them wasn't created because we squared both sides. Or both of them don't work. Okay, so it could be that none of them work, that both of them work, all three of them work, whatever you have Half of them work, so you do have to check each one. Just because the first one worked doesn't mean the second one will or won't. You can't make that assumption. So you have to check your work on that, okay? So let's do a bunch of different examples, and hopefully I'll hit every type so that when you do the homework, you're not like, oh, she didn't teach this. I really do my best to do that, but I know sometimes that problems come up with the homework sometimes, and I didn't teach it. If that happens, circle it. We'll do it in class. Okay, number 1, square root of y minus 7 equals 0. And over here I have check. On all the problems, I don't want you to forget to check. So I put that word so you would remember, all right? Step 1 is to get the radical by itself on one side of the equation. Well, this minus 7 is outside the radical. So we're going to add that to both sides. So now we have the square root of y equals 7. The radical's by itself on the left side of the equation. Now we have to figure out the index. The index of a square root is a 2. Remember, that's understood. There's an understood 2 here. We don't write it, okay? Which means we need to square both sides. In this case, it just simply gives you y. Because now here's where people do all kinds of weird stuff. The square root and squaring it just undoes it. So it's gone. And we have 49. So now we have to make sure that works. So when you do a check, remember, we're not moving things from left to right. We're just seeing, does one side equal the other? So you take your original, your very first line that was given to you, and this is what we're checking. We don't move things from side to side. We put in what we got as an answer. So we got 49 as an answer. And we check to see, does that equal 0? And in this case, it does. You can see 7 minus 7. You don't have to do all of these steps, but you have to do something to check it so that I can tell you took the time to check it. You could skip from this one to this one, probably, okay? And say that's true. All right, let's go to number 2. The square root of negative, whoops, sorry. Just getting ahead of myself here. At y minus 2, minus 1 equals 5. This is where I see people try to do this. What this actually means, don't write this down, is that you're doing this. And I don't know why you'd want to do this. It'll work eventually. Okay, then you have to FOIL that. So that will get y minus 1. And then you'd have to do this, negative square root of y minus 2. And you're going to create all kinds of issues. If you follow the rules, the steps that I gave you, it's going to make your life easier. But you got to remember the steps. We do not square or raise it to any power until the square root's by itself. So in this case, we need to add that 1 to get it over here. Legal move. You're allowed to do it. I don't know what I was doing there. Whoa. Okay. Add 1. Now we have the square root by itself. And now when we square, we don't have to FOIL, we don't have to do anything. We just need to undo the square root. This makes our life easier. So we square both sides because the index on that root was 2. That simply undoes the square root. If the square root's by itself and you square it, you're done. You undo it. You don't have to do any kind of multiplying or FOILing or box. Okay? You finish it out. It appears that y equals 38. Let's check and make sure that we didn't create a solution that doesn't work. So we have square root of 38 minus 2. Minus 1 on the outside, is that the same as 5? And whoops. And for some of you, you might be able to already get to the answer. But what you're going to get here is the square root of 36 minus 1 equals 5. Is that true? Well, yeah, because it's 6 minus 1 and 5 equals 5. Your checks don't have to be long and laborious, just enough to check yourself. It worked. I'm good. This is truly an answer. Okay? Let's go to number 3. I know I'm moving quickly. It's just I want to do a lot of problems so you can go back and slow down the problems you want. Now on this one, it's a little bit different. We have roots on both sides. But the good news is there's nothing outside the roots. So we can just square, and they both have the same index. So they're really alone on the side of the equation. If you move the one over and equal to 0, again, you're going to end up FOILing square roots, which is possible, but cumbersome and confusing. So let's just square both sides. What does that do? It undoes the square root. So 2t minus 7 equals t plus 2. Now we just solve the equation. Minus t, t minus 7 equals 2. Add 7, t equals 9. Okay, that seems to be the answer. So let's check and make sure there's actually a solution to this equation. So we have the square root of 2 times 9 minus 7, and is that equal to the square root of 9 plus 2? Well, this is going to be the square root of 18 minus 7. Oops, I said plus 2 and I wrote 9. And this is going to be the square root of 11. Is this true? Well, yeah, this is the square root of 11 equals the square root of 11. It doesn't matter what they equal each other, so this is a true statement. Therefore, t equals 9 actually does work. Let's look at number 4. Number 4 is a to the 1/2 plus 9 equals 0. Usually when I'm going to do something like this, I just immediately change this to the square root of a plus 9. And then I just proceed. I minus 9 from both sides. Now some of you at this point, you're going to say, this isn't going to work. And why is that? Because the square root, there is no way to square root something and get a negative answer. Now some of you are going to not see that, and that's okay. So let's just finish it. Like maybe you're just moving along, you got this under control, square both sides, and you're not really thinking too deeply about it. So a equals 81. Looks like that works. Let's try it. Make sure that it works. So even if you don't notice right away that that's not true, when you do your check, you're going to figure it out. And so you just did a couple extra steps. It's not a big deal. So is this true? And most of you can already see that this is not true. Square root of 81 is 9. 9 plus 9 does not equal 0. Therefore, there are no solutions to this problem. No real solutions. There are imaginary solutions, which are awesome. I love imaginary numbers. I believe we're coming to that very soon. They're awesome. I know you've been waiting since freshman year to know what an imaginary number was. Don't get too excited. We still have another lesson or two to get to. Okay, number 5. 3y plus 1 raised to the 1/3 plus 5 equals 0. Again, I have so many people that want to start squaring both sides right away. Don't do that. This is the third root of 3y plus 1. Outside that root is a plus 5. The minute we have something outside that root, fix it. All right, so I'm going to subtract 5 from both sides. Now, don't make the assumption here that this is not true, because we have a cube root. A cube root, an odd index can result in a negative answer. So this may or may not have real solutions. Now, in this case, remember, this is the cube root, the index, so that means we have to cube each side to undo a cube root. Squaring it's not going to undo it. Okay, so that's 3y plus 1 equals, crap darn it, what's negative 5 times negative 5 times negative 5? It's negative 125. Shoo, I was able to do that. Subtract 1. So 3y equals negative 126. Divide by 3. Y equals negative 42. Let's check it to see if that's an actual answer, if this equation actually has an answer. Okay, and again, I wrote the word check because I'm not trying to trick you into forgetting it. So 3 times negative 42 plus 1 raised to the 1/3 power plus 5, does that equal 0? You could actually put this left-hand side right into your equation. You can raise an expression to a 3rd power on your calculator. But this would give you negative 126 plus 1 to the 1/3 power plus 5 equals 0. This is negative 125 to the 1/3 power plus 5. Is that going to equal 0? Well, the cube root, or negative 125 to the 3rd power, is negative 5. And so this does work, and therefore this is a correct solution. One more. Number 6 is kind of confusing. So pay attention. This is the hardest one you're going to deal with. Otherwise, you're just going to square or cube both sides and be done. This one, here's the problem. You have a square root on both sides. No matter what you do, you're going to have a square root, and it's going to be plus or minus another square root, so you could move it, but it doesn't matter. So at this point, one of the square roots is by itself, so let's square both sides. And you have to be really, really careful with this, okay? So this is going to give you x minus 12. This really means 2 minus the square root of x times 2 minus the square root of x. The whole thing has to be squared, which means we have to FOIL it. So that's going to give us 4 minus 2 root x minus 2 root x. And this is going to give us plus, because it's negative times a negative, x times x. Now watch what happens. This is going to be 4 plus, whoops, not plus, minus 4 root x plus x. Now we only have one square root, so we're going to start back at the top of the list and we're going to get the root by itself. So we're going to subtract 4 from both sides. X minus 16 equals negative 4 root x plus x. We're going to subtract x from both sides. This is turning out nicely. We get negative 16 equals negative 4 root x. Still, I don't have the square root by itself because of that 4, so I'm going to divide both sides by negative 4. And now I have the square root of x equals 4. Square both sides to undo. We have 16 equals x. You may have to watch that more than once to see how I did that. You know, sometimes you have to go back and do a little extra work. So now let's do the check and see if it actually works. 16 minus 12. Square root, is that going to be the same as 2 minus the square root of 16? So let's see, 16 minus 12 is 4. And then we have 2 minus 4, so this gives us 2, and this gives us negative 2. They are not equal, therefore there are no solutions. So all that work, and it's no solution. Okay? All right, one more part to this section, is solving radical inequalities. Not much different. Same steps, really. There's just one extra little thing you have to do. Okay? You're going to first get the radical by itself, just like before. You're going to determine the index and raise it. I'm shortening it because it's the same steps as before. And raise to that power. You're going to solve. You're going to check. And then there's going to be one more step. You're going to set the equation, the expression, under the radicand. Whoops, sorry. Greater or equal to 0. And I should have wrote this the other way. If the index is even. If the index is even, we cannot have a negative number under the radical. If the index is even, we cannot have a negative under the radical. So let's do number 7. 3 root a is greater than or equal to 12. Again, the radical's not by itself here, so divide both sides by 3. We did not divide by negatives, so we don't have to flip the inequality. So square root of a is greater than 4. Square both sides. So we get a is greater than 16, or equal to 16. So if we do 3, so here's my check. 3 square root of 16, is that greater than or equal to 12? So this is going to be 3 times 4, and that is equal to 12, so this works. If that works now, we know we have a solution. What we have to say is a has to be greater than or equal to 0. So that's also part of it. Okay, let's look at number 8. 1 plus the square root of 7x plus 3. I got to go back to this one. I keep thinking about this one. Since we already said that a is greater than or equal to 16, we don't necessarily have to say this part. Because a is already greater than 16, that means it's already greater than 0. So this part wouldn't be necessary in that problem. It wouldn't be wrong to cite it, to say it at this point, but we wouldn't necessarily need it because we already know that a is greater than or equal to 0. Okay, so now we're going to subtract 1 from both sides. 7x plus 3 is greater than 2. So the index here is squared, so we got to square both sides. Okay, so we have 7x plus 3 is greater than 4. And now we can just finish this off. Just be careful, if we divide by a negative or multiply both sides by a negative, we have to flip that inequality. That's the weird thing with inequalities. Oh, this one turns out yucky. Ugh, I don't like this problem at all. All right, well, let's see what happens. So we get x is greater than 1/7. Right? Okay, let's see if that's true. Let's check it before we finish it. And it says the square root of 7 times 1/7 plus 3, is that greater than 2? Ooh. I gotta think about this one, because that's going to give you the square root of 4, which is equal to 2. As long as we stay greater than 1/7 and not equal to 1/7, we're good. Okay, so we could put 2 sevens here and that would work. Okay, so this checks out. This is a correct answer. However, we also have to take that 7x plus 3 and we have to make it that greater than 0 or equal to. You're allowed to have 0 under there. All right, so we cannot let it go below this. So let's check to see if we need a second part to this. So 7x is greater than or equal to -3. Divide both sides by 7. And it says x has to be greater than -3/7. Well, is x already greater than or equal to -3/7? Well, it is. So this part we don't have to state because we're already saying that x has to be greater than 1/7. But we have to check to make sure what's under the radical doesn't go underneath 0. Okay? Let's try one more. 2 more. Number 9. Come on, you stupid thing. Oh, did my pen just run out? Seriously? Hold on. Let me plug this in. I can do it with my... We're almost done this. That's why I don't want to take any more time. I did get a notification that my pen was almost done. So number 9. Let's see if that'll do it really quick. Okay. So number 9 and 10, I will try to have time to go back and fix, but my pen just ran out, and I'm trying to remember if I can... Oh yeah, draw with touch. Let's see if I can do this. So number 9, this is not going to go well, but let me just show it to you. The square root of 3x minus 6 plus 4 is less than or equal to 7. We're going to minus 4 from both sides. So now we have the square root of 3x minus 6 equal, whoops, sorry. This is so weird doing this way. Okay, erase. Is less than or equal to 3. Oops. The index is squared. So we're going to square both sides. I think I have to do 2 fingers if I'm, yeah, okay. Just trying to figure this out when I'm using my, so that's going to be 3x minus 6 is less than or equal to 9. Add 6 to both sides. 3x is less than or equal to 15. Divide by 3, and so we have x is less than or equal to 5. Okay, so let's check it. I keep drawing these lines because I'm so used to using a pen. So let's check it. Okay, if we check it, the original was the square root, I can't write small, 3x minus 6 plus 4 is less than or equal to 7. So let's see if this works. If I do 3 times 5 minus 6 plus 4, is that true? So this is going to be 15 minus 6, which is the square root of 9, plus 4. Is that less than or equal to 7? 15, so that's 3 plus 4. So yes, we're less than or equal to 7. So that works. Now we have to make sure that we are not letting what's underneath the radical become 0. So underneath the radical, we had 3x minus 6. So let's do 3x minus 6 has to stay greater or equal to 0. We might be okay, but we might not. We may need to add this might have to be a need to add a second boundary. So we add 6 to both sides. 3x is greater than 6. So that means x has to stay greater than or equal to 2. So we really have two boundaries. X actually is between two things. X is bigger than 2, but less than 5. So x could be from 2 to 5, but that's it. Because any other thing would cause a negative number under an even index, which causes an imaginary number, which we're not doing right now. Okay? So that doesn't give you a real solution. All right, let me do one more. And then I better charge some things here. Number 10. Is 3 the square root of 2x minus 1? Let me see if this works really quick. Oh yeah, I think I got enough charge. Let's see if I can finish it out. Is less than 15. Okay, we're going to subtract 6 from both sides. And like I said, I'm moving quickly because hopefully you understand some of this. If not, come back and slow it down a little bit or watch it more than once. Okay, divide both sides by 3 to get the radical by itself. Oops. Okay, square both sides, because that's the next step. Now we just use our rules of algebra to finish this off. Plus 1, not dividing by a negative, so we don't have to flip the symbol. So x is less than 5. Let's see if that works in our original equation. Our original equation was pretty confusing. It was this, so here's my check. It was 2 times 5, I'm putting that in instead of my x, minus 1, plus the 6, is that going to be less than 15? If I do that, if I keep the number in there less than 5, will that keep us less than 15? So you kind of got to think about this logically, because this is going to equal 15, I believe. Yeah. But we're saying we're going to keep it less than 5, so this will work. This is true. Because as long as we stay less than 5, which is what we said we're going to do, then this will work. This will keep us under 15. Okay? Now we have to make sure, do I have to have another boundary? So what was under my radical was 2x minus 1. That has to be greater than or equal to 0. So I add 1 to both sides. 2x is greater than or equal to 1. Divide both sides by 2. And x has to be greater than or equal to 1/2. Therefore, we do have two boundaries now. Okay? We have, I know, I'm going to charge you in a minute, that x has to be greater than 1/2, but x has to be less than 5. So it could be equal to 1/2, x can, and it can go as high as 4.9999999, and that's as high as it can go. Okay, so that's section 5.8. If you need some more help with that, because I kind of went through some of those quickly because my pen was dying, and now this is dying, then let me know. We'll do it in class, and we'll go over some of these problems in class.